In this video, we're going to be plugging in f of x into the definition of a derivative. Once we find the derivative, we're going to use it to find the equation of the tangent line at x equals 2, as well as the normal line at x equals 2. I'll also show you what this looks like graphically, but we'll do that later. Let's begin. So they gave us f of x is equal to 7 minus 3x plus x squared. How do we find f of x plus h? Well, we can change all the x's to x plus h. So I'm going to change this to x plus h. Okay, and then minus 3 times x plus h. And then plus, this gets changed to x plus h as well, so it's going to be plus x plus h squared. Okay, so let's go ahead and change this to this. Okay, so 7 minus 3 times x plus h plus x plus h squared minus, what goes next? Because f of x is equal to 7 minus 3x plus x squared. So let's plug that in. 7 minus 3x plus x squared all over what? All over h. Okay, how do we simplify this expression? Well, we're going to need to simplify what's inside the brackets first, so get rid of the parentheses. Let's go ahead and do that. So negative 3 times x, that's minus 3x, negative 3 times h, minus 3h, plus, what does this simplify as? This is going to simplify as x squared plus 2 times this. So 2 times x times h. I'm going to do 2hx because I like to leave things alphabetical. And then, all right, plus h squared. Okay. And then I'm just going to copy the rest of this. Okay, so to summarize, what was the point of this step again? The purpose of this step was to plug in f of x plus h as well as f of x. What was the purpose of this step? It was to simplify this expression. The purpose of this step was to get rid of the parentheses. Okay, now we need to get rid of the brackets. So how do we do that? Okay, so 7 minus 7 is 0, so that means these are going to cancel. Negative 3x minus negative 3x. Anything minus itself is going to be 0, so we can just cross it out. How about negative 3h? Is there a negative 3h over here? There isn't. Okay, so we're going to leave this by itself. How about x squared? Yes. Okay, and since we crossed out everything over here, that's it. We don't need to do anything here. So what are we left with? We're left with minus 3h plus 2hx plus h squared over h. How do we simplify this expression? Is there anything we can factor out on the top? Yep, we can factor out in h. So h times how much is negative 3h? Times negative 3. H times how much is 2hx? 2x. And then h times how much is h squared? H. Okay, what can we cancel here? So what does this limit become? How do we calculate this limit? We can plug in 0 for h. So this turns into negative 3 plus 2x. I like to write it as 2x minus 3. I just like to keep the x's in front. But this is the derivative. Derivative. Okay. Now we're ready to move on to finding the tangent line at x equals 2. But before we do that, I want to show you what this looks like graphically. What kind of graph is this? So you can think of it like this: x squared minus 3x plus 7. This is the graph of a parabola because of the x squared here. So this is what it would look like. Okay, but with our problem, we're interested in what happens at x equals 2. What happens at x equals 2? So what happens at x equals 2? Because 0, 2, 4, 6, 8, 10. I'll just label these 4, 6, 10. I'll label these. All right, we'll just do this for the sake of completeness. Oops, this is supposed to be positive 12. Okay. All right, so what goes on when x is equal to 2? So at this point. So we want to draw a tangent line at x equals 2. So basically what that means is draw a line that only touches this graph once, and it touches the graph here. So I'll show you what it looks like. It looks like this. That's the tangent line at x equals 2. Okay. And what do they want us to find? They want us to find the equation for that, for that tangent line. Okay, so to find the equation of a line, what do you need? You need to know the slope as well as have a point on that line. We're going to use this point later, but let's first find the slope. Okay, so to find the slope, we can use the derivative. Slope. Okay, so the tangent line at x equals 2, the slope is going to be what happens when we plug in 2 into the derivative. So 2 times 2 minus 3. So the slope is 1. Okay. Slope is 1. You can kind of eyeball it here. You can kind of see that the slope here is 1. Okay. What's next? We need to find a point. We said we were going to use this point. So how do we find the coordinates of this point? Okay, let's suppose we didn't have the graph to work with, because with the graph you can kind of eyeball it. Okay, so no graph. How do we find? So suppose we don't have the graph. How do we find the point? Well, okay. So the x-coordinate is 2. All right, you can see it here as well. The x-coordinate is 2. Oops. Use the one that I labeled. The x-coordinate is 2. All right, but let's say we didn't have that graph to work with. Let's say we couldn't eyeball the coordinates of this. What would the y-coordinate be? So it would be f of 2. And how do we get f of 2? Change x to 2 in this equation. So 2, and then it's going to be 7 minus 3 times 2 plus 2 squared. Okay. So 7 minus 6 plus 4, so 5. All right. So 2, 5. Let's double check. So 2, and then 2, 4, 5. Okay, so that's right. Okay, and once we have the slope and a point, we're ready to find the equation for the line. What formula should we use? Y minus y1 is equal to m times x minus x1. What do y1, m, and x1 mean? y1 is going to be the y-coordinate of your point, so 5. M is going to be the slope, and x1 is going to be the x-coordinate. Okay, let's get y by itself. So this is y minus 5 is equal to 1 times x minus 2, so just x minus 2, and y is equal to x plus 3. Now, what does normal line mean? So basically, normal line at x equals 2 means we're drawing a line perpendicular to this line. And since we're at x equals 2, it's going to also go through this point. As the x-coordinate of this point is 2. Let me show you what it looks like this. Okay, so this line is perpendicular to this line. So what would the slope be? There's a formula for that. So it'd be negative 1 over the slope of the line that it's perpendicular to. So that tangent line. Okay, so negative 1 over this number, negative 1. Also, since the normal line also goes through that same point, we can reuse it. Here, I'll just label it. Right, since we used this earlier for this tangent line. This line also goes through it. We figured out the slope. We also know that it goes through this point. So now we're ready to find its equation. All right, it's the same process as earlier. So y minus y1 is equal to, this time slope is negative 1, so be careful. X minus 2 okay, this is your answer. So I'll label the lines real quick. Y equals x plus 3, y equals negative x plus 7. And yeah, I'll just write tangent line. Tangent line at x equals 2, normal line at x equals 2. As a challenge, I want you to try doing this problem on your own. So we're plugging in f of x into the definition of a derivative, except this time we're finding the tangent line at x equals 1 as well as the normal line at x equals 1. I'll include the solution in the comments.